Also, if I see that everyone has put in their answers, I'll just skip ahead past the timer. It's pretty much just there if you need it. Okay. Wow. A lot of interesting answers. Okay, so the majority of you guys did not get that right. Um, okay. Do you guys want to go over that one really fast? How to do that one? Yes? No? Yes? Okay. So for this one, yeah, I might have to do it like this, and then take this out. And then, so basically for NaH, I had said that when you do this, that the Na, because it's a cation group 1, it can have the oxidation number of 1. So here, let me write it down. So NaH, for this, Na would actually, you just take the oxidation number of Na for this one because it's a group 1 cation. So that'll be 1. And then in this case, it would actually be plus -1 to get 0. Therefore, hydrogen is not +1. Do you understand that one? Yes? Are we good on this? Yes? No? You guys write something in chat. Yes. Okay, great. Okay, so let's go to the next one. Okay, good job. Next. Again, if you don't get it, it's fine too. In the equation 2Na plus H2, it goes to 2NaH. Hydrogen is what? Did end up getting that right. Now, loses electrons and oxidizes is actually the same thing. So if you put the red or blue, you would actually have the same answer. But yeah, it's reduced. And does anyone know why? Can anyone say why? Why is it reduced? Does anyone have an answer? Any explanation? Or from 0 to -1. Yeah, you can do it mathematically, or if you want as well, what you can say is that because H2 goes to, it adds Na from the 2Na, it gains electrons. It gains electrons, that's reduction. So, do you understand that one? Is that one okay? Yes? No? Yes? Yes? No? I don't know. Okay, great. So I need to make sure, because I saw on my pre-review that someone said when they watched my session that I don't make sure that everyone knows, or like, I don't check for understanding enough. So I want to do my job better. So sorry if I keep asking, are you guys okay and stuff like that. I don't want to get in trouble. So let's just keep going. All right. Okay, next. Oxidation is the loss of a proton. Okay, 2 trues and 3 false. Okay, does anyone can tell me why it's false? Fine. It's okay. There's only like 6 people here. Like we're not all judgy. And plus, most of you guys I have seen. It's not your first session. It's electrons. Yes, exactly. It's the loss of an electron, not a proton. That's a trick question. Loss. Yep, exactly. See. All right. Next question. Yes, Dolores. Okay. Okay. What's the change in oxidation number, basically? Okay. Cr042 minus to Cr3 plus. You're doing oxidation numbers. I put 2 minutes on this one, so you guys don't have to freak out on time. You already have your answer. You're like the one of the 3 people. You can just like chill, check over your answer, make sure you got it right and stuff. Then if you're still working, I think I'm gonna end it maybe at. I'm just gonna wait it out because I just want to see like what you guys got for your answers and not rush it too much. I think I actually enjoy having a smaller group of kids versus the other sessions where I used to have like 20. It's nicer. Okay. All right. Okay, for the most part, we got it right. Does anyone want me to go over it? Because I saw someone put increase by 5 minutes. Maybe that was a guess. Are we good on that one? Does anyone have any problems? Yes, no? I do? Okay, I kind of guess. Okay, let's go over it then. All right. And then you guys can see my other PowerPoint, right? Like on the side, like where I'm writing. Yes? You guys can see that, right? I'm not just crazy. Great. All right. So we have CrO4 and then goes to, okay. I can actually erase on this one. Look how nice that is. Finally, I can erase. Okay, so starting with the first one, CrO4 to -2. It's going to equal to -2 specifically. We have to have it like that, right? Because it's an ion, right? And then what's the oxidation number of oxygen? Can anyone tell me that? What's that going to be? -2, yes, exactly. So because we have -2, we're multiplying it times 4, right? Because we have 4 oxygens. So because of that, what's x going to be? So that's -8, right? -8 plus what equals -2? Yeah, that's -8. So what's x going to be? Can anyone tell me? 6. Yes, exactly. X is going to be 6. So that's for the first one, right? So now that we're going on to the second part, and we have Cr3 plus, what's that going to be? That's an ion too, right? So what is that going to equal? Can anyone tell me? 3. So wait a minute. Is what with another number? -8, that's the oxygen. That's O4. That's the O4. X is the Cr. And then -2 is the ion. Yeah. And then Cr plus 3, again, that's an ion. They pretty much give it to you with the 3 part. So Kosh is right, it's 3. That's the ugliest 3 I've ever seen. But as you can see, that's a 3, which is why it decreases by 3 units. Great? Understood? Yes? No? I don't know. Do y'all understand that part? I think the majority of you guys got it right. Great. Okay, next. Okay. Next. Okay, great. Okay, let's keep going. Okay, what products are formed in this neutralization reaction?
Your mouth.
NaOH equate, whatever, plus H2SO4. What are the products of this neutralization reaction?
Yeah, you lay riêng.
Okay, if you're still struggling on this one, remember it's a neutralization reaction. Remember neutralization. What products come up from that? Okay. And so, okay, great. The majority of you guys got it right, and there's one person got it wrong. Do you guys want me to go over this one? Yes or no? Put the wrong one. Okay, did you understand which one was right though? Stephanie? Yes. Okay. So we all got this one right, so we're good on this one. Yes? We're all good on this one? Yes, okay, great. So then I don't have to go over that one. And if you were confused, neutralization, you need a salt. Wow, Sammy has the streak of 5 correct answers in a row. Great. Okay, NH3 is the gas given off in the reaction between NH4, NO3, and KOH. True or false? And again, this is products as well. Find the products.
Wait, did he say it?
Oh gosh. Wow, I had no idea. Well, yeah, don't worry. No one else did either. You're all good. Um, I really thought for a second that the 5 people that got it right were like, it was right, not wrong. I was like, wow, you guys all got it right. And then I looked for a second. I was like, oh. Okay, so clear we have to go over this one. Okay, let me erase this. And then we'll just do that one. I had a feeling that this one might be tricky. But I seen along the group me that people complain that things is too easy for them. Or Dr. Kelly goes over things that are way too easy and then the test is hard. So I don't want to give you guys questions that are like too easy and then the sessions are worthless. So NH4 with NO3 plus KOH. Okay, the products of this is gonna be, and I'm gonna explain this because no one got it right, is that you're gonna end up getting KNO3. Again, you're doing cation with the anion, right? NO2 is minus, and then potassium is positive, right? You're writing something down. Yeah, I'm writing on the board. Can you guys not see the board? You guys can't see it. Okay. Yeah, let me stop sharing for a second then. And then let me go back. Sorry, I thought you guys could see that. That's so weird. Here, let me share this. And then, here, I'll do it like this then. I think that's better. Can you guys see the screen now? There's nothing on there, but you guys can see. Okay, great. Let me start from there then. And I remember the question, so it's fine. Okay, NH4 NO3 plus KO OH. And then the products of this is going to be K and O3 because, yeah. And then, what happened to my screen? Hold on, sorry. I don't know why that happened. Maybe I pressed something, sorry. But again, you saw the reactants, right? It goes to, and the products go to KNO3. That's one of the products you get. And then it also goes to NH3 plus H2O. And then when you break this all up, because the original was NH4 NO3, right? What gets broken up? Can anyone tell me? Which elements? Can anyone tell me which one of these gets broken up? Not water, right? The NH4. Okay, do you have any other answers? Besides NH4, does anyone else have an answer? Yes, no, I don't know. If you don't know, it's fine because I can tell from the answers. So, anyone else have anything else they wanted to say? You don't know, where did the K go? Maybe it's just the way I wrote it. K is right here, and then the product is KNO3. Do you see it now? Yeah, KOH goes to KNO3. Yeah, that's like, yeah, I'm sorry, I'm writing on computer, so it might be tough. But when you do this and you write it all out, NO4, NH4, and NO3 split, and then K and then OH also split as well. And then pretty much all of it splits up except for this. H2O does not split up. It's also a gas in this case. So you're just not going to break up H2O. Usually when you see H2O in something, you're not going to break it up. You don't need to. You probably never do anyways. So that's going to stay. Make it H2O. Yeah, if it if you see H2O, then obviously like it donated or gained electrons to be able to make that H2 at the end as the product. So when you do all this, again, NH4 and yeah, NH4 and NO3, it breaks up to becomes two separate things. Same thing with K and OH, and then you do the same thing with K and NO3 as well, and then NH3 stays the same. So because of this, you have NH4, you need to cancel that out, and then you also have K. You have K on both sides, you cross that out, and then what else happened? Yeah, actually, this can stay there actually in a way, but any NO3 gets crossed out. So this stays kind of in a way, and then obviously H2O stays. And then the only gas that's left is NH3. Do you guys get that? Like certain things get crossed out, but then other things stay. So that in the end, all you have is NH4, and it goes plus OH, which then goes to NH3 plus H2O. Do you guys understand that? Yeah. Those are the only things that get canceled out. And then the only gas that's here, like H2O is not, it's not a, well, it's a gas, but it's not the final answer, right? Because H2O is kind of just there. We're going to do H and H3. So do you understand how we got that? Again, it's just net ionic equation. We're good on that? Yes? Okay, great. I'm going to share the screen again. Hopefully it goes a bit better. Okay. It should be, okay, great. Okay, next, can you guys see the screen? Yes. And stay the same. Yes, great. Okay, next. In the reaction Zn plus PbNO32 to ZnNO32 Pb, the reducing agent is, and I think this is what I was telling Dolores, this is the other equation, or other problem I have with reducing and oxidating agents. So in this, what's the reducing? Remember, reducing agent is the one that gains electrons. So look for which one gains electrons. A 10-second warning. If you don't know, just put in your best guess as well. Okay. So, was there some confusion on this? Do you guys want me to do it? Yes, no? Just can you go over it? I guessed. Okay. Yeah, of course. Alright. Okay, can you guys see my PowerPoint thing on the side? Or yes or no? Yes, no? The thing I had originally? Like the split screen, can you guys see that? Nope? Okay. Oh my god, I hate that. Okay. I don't know why it doesn't work. It makes me very angry. Wait. Okay. Screen, this one, share. Okay, let's go down and figure that one out. Okay, let's write it out. Okay. Actually, I don't need to write this one out. You have Zn, and it goes, like, if you look in the thing, remember how it had Zn, and then I went to Zn, what was it, PO4, I think, or something? What was it? Yeah, NO3, yeah, it goes to NO3, 2. There's a gain of electrons here. Do you see that? It gains electrons. There's a gain of electrons. Or you can do oxidation number, and you would see that it also gains. Once you see it gains electrons, then you would know it's reducing agent. Do we understand that? Yes, no, yes. Yeah, again, like that one was like, I think if you just knew the rule, then it would be easier than writing out the oxidation number of ZnNO32. NO32. Honestly, I don't remember what NO3, like the oxidation number for that specifically was, like what that ion was, but I'll write it out. Like if you need help with that in a little bit, then I'll write it in the email. I'll write it down here. Let me see. What question was this? Number 7? Um, Anything else? Like, did you guys need because I don't know that off the top of my head. The NO3, like I don't know how many oxidation number that is, like for that ion. So, anything else? Like, do you guys have a question on something? You're good then. Then okay. PB was the reducing agent. No, PB. When I believe that would then be the oxidating because it loses electrons. It goes down. It went from PB NO32 to just PB. So it's the opposite way. It loses electrons. Yeah. Again, that's where it's like the inverse thing, where reduction is gaining, and then yeah, that happens sometimes. Because this is reduction, so you would think it goes down, but chemistry is just boring. Mentally, I got it right. I do that all the time, and then I say the wrong thing, and I sound like so dumb. You probably noticed already. Anywho, let me share the screen, and we'll keep going. Okay, I'm gonna share my entire screen. I think that's why it wasn't working. Okay. Oh, perfect. You guys can now see the split screen, right? The thing on the side. Yes? Okay, I'm just gonna assume yes. Okay, so let's keep going then. Yes. Okay. In the following chemical equation, what are the spectator ions? And you have 2 minutes for this one. So AgNO3 aqueous plus NaCl aqueous to AgCl solid precipitate, and then NaNO3 aqueous. What's the spectator ions? I just realized there's 2 answers of the same thing.